Hey gang, this is Mr. Schmidt for Environmental Science on October 15th. We're talking water cycle and the introduction of Earth cycles here. A lot of my content we're doing today actually comes from the U.S. Geologic Society's Water Science School. If you have any questions beyond what I can answer, this is always a great resource. They go everything from the beginning elementary school content all the way up through graduate school and professional um, information with their publications here. Okay, so always feel free to look for more information from the highest sources. And the U.S. Geologic Society really does a great job of tracking and explaining water. Okay, all right, so let's start with the basics here. We're going to be trying to draw and label a water cycle. That's our big goal. Okay, so this falls within a bigger standard of analyzing a major um, global change to a specific qualitative and quantitative criteria, in our case, water, and constraining solutions, such as how do we conserve water uh, to account for societal needs and wants. So what we're going to be doing is identifying constraints within the water cycle and how it's being measured. Measured is particularly tricky in the whole water process. So right now we're just going to worry about labeling their sources and looking at some of those numbers that the U.S. Geologic Society has for their measurements. Okay, so you'll see the Geologic Society refers to it as the water cycle or also the hydrologic cycle. Hydro just meaning water in this case. Okay, so it describes the continuous movement of water on, above, and below the surface of the Earth. If you ever go on to take astronomy, you'll find out that water can be found on a few other objects as well, which has been a fairly exciting discovery in astrophysics as well. All right, water is also changing states between liquid, vapor, and ice. Okay, so we'll be talking quite a bit about solid liquids and gases in this process. With these processes happening in the blink of an eye, such as your water evaporates or your water turns into from steam into a liquid, that can be very fast. It can happen in the blink of an eye. Or sometimes you have things like glacial movement, which happens over millions of years. Okay, so the water cycle really spans the extremes of our time frames. Okay, so this one picture really describes a great deal of what we're trying to focus on today. It's also a very good model for looking at the assignment and how do we label everything. So if we start at the ocean, we're going to find out in the numbers that the ocean accounts for huge amounts of the water on Earth. Okay, so the most common thing that happens to start this cycle is that with all this water in the ocean, some of it evaporates. Okay, with that evaporation comes condensation. Okay, so we see water condenses around specific dust particles. You do need particles in the air to form clouds. So the water vapor turns to liquid droplets on those dust particles, and that's what forms the clouds. And then as those dust particles and those droplets become bigger, we start to see it moves through the atmosphere, and eventually the droplets become big enough, they fall, and that falling is precipitation. Okay, and that can be snow, it can be hail, it can be rain, it can be any type of water falling. Okay, one of the more interesting but smaller sources of water entering the atmosphere is also from volcanic steam. Okay, so once we get all the water in the atmosphere, it comes down through precipitation. It hits the ground. Normally, the first thing it does is move across the surface of the Earth for a short period of time. That is runoff. Okay, then it's either going to hit a stream or it's going to start to move into the soil. That's called percolation, as it moves into the soil and does infiltration. It can sink all the way down to the aquifer and stay as stored water, or it can move through the soil in groundwater flow, or what's sometimes called underground rivers. Okay, that underground flow can then seep back up slowly to form kind of damp areas where there's seepage, or it can come out as a pressurized water source and you can have a freshwater spring. Okay, and that spring will then feed down along with the runoff and the streams to form freshwater lakes. Okay, which of course will have another point for evaporation to occur. Okay, so here we see surface runoff can happen both mountaintops or along the hills or any place where we're getting any precipitation. Okay, it'll also flow into the plants and animals. Okay, plants are going to have a big part of this as the plants take up the water and their roots. They can then let it out through their leaves. Okay, which would bring us to transpiration, which I don't see on this one right here. Okay, I guess we can call it evapotranspiration. Okay, as the plants are giving off moisture through their leaves and it goes back into the atmosphere. Okay, and then one of the more interesting ones, especially at high elevations, where you have lower pressure and low humidity, you can have snow and ice turn directly from solid into gas. Or at the right low temperature conditions, you can have gas turn directly into ice without ever forming a liquid. Okay, so the sublimation desublimation process entirely skips the liquid phase and goes solid to gas, gas to solid. Okay, so this is our big chart here. We're going to see all this kind of explained again in writing if you're not a picture person. Okay, so precipitation, like I said before, it is all the falling water. So the examples of precipitation are rain, snow, sleet, hail. You can have some other unique categories such as freezing rain. There's all sorts of combinations, and when we get into our weather unit, we'll talk quite a bit about this. Okay. Sleet is one of the more interesting ones because it's kind of wet snow. Hail forms in the cloud, and it is a frozen water chunk of ice falling from the cloud to the ground. It goes through a whole wind process. Again, I don't want to describe it too detailed right now, but it comes down as ice when it hits Earth. Okay. Infiltration is once it hits Earth, a lot of it's going to go into the soil, going through the cracks and the dirt and the rocks. And that is the infiltration of the water into Earth. Okay, if the water doesn't infiltrate the soil, that's going to move across the top of the soil, and that is the runoff, as the water moves over the surface of the soil, normally ending up in streams or ponds. Okay, so we talked about measurement and about these numbers. So when we look at all the water on the Earth, and the Earth really does have a lot of water in it. Okay, when we look at all that water, 96% of it is in oceans. And when we add in other water or saltwater sources, we're up to 97%. Okay, so places like Salt Lake, okay, there's a lot of salty water sources, which is important for us to note because as humans, it's not good for us to drink salt water. And all the plants that we grow on the surface of the earth also cannot survive in a saltwater condition. So we rely for our survival on this 2.5% of fresh water. That 2.5% gets broken down into other things that we still can't use. Glaciers and ice caps. So if we're talking about the tops of the mountains where the ice stays permanently frozen all year long, that is a glacier, and it stays a glacier for thousands of years. Okay, same with ice caps. It remains frozen in snow and ice for years and years. Okay, we'll be talking about this later. Some of that water is now melting, which causes a great deal of problem with the sea levels. Okay. Though fresh water is also held underground, which is incredibly important for agriculture. So if you have a well and that's where you're getting water to drink, that's groundwater. If you're like in Kansas, where you want to water your fields every day to grow corn or wheat or whatever you're growing, you're pulling out of these great big sources of groundwater called aquifers. And there's a lot of water there, but if we pull water out faster than it's being replaced, then either it's going to run dry or a salt water source is going to start filtering into that place, okay? Which again would leave it useless for us to then drink it or put it on our fields, okay? So when we're looking at drinking water, especially around here, a lot of our water comes from freshwater surface sources, okay? Those other sources, they say other, but really it's the biggest category: ground ice and permafrost, okay? So glaciers are all the ice that's sitting on top of the mountain. But if you're up in Alaska or Siberia and there's water just below the surface and it is frozen and it stays frozen all year long, that is permafrost, okay? Which is important for our water cycle. It's also important if you want to do things like build houses and roads through Alaska. You don't want to do it on top of permafrost, because if any of that water melts, your house can tip over or your road can break. So it becomes a great big engineering challenge of how do we build things on top of permafrost, and what happens when permafrost melts. So again, we're seeing at increasing rates, okay? Permafrost also holds a lot of carbon dioxide and other carbon sources, which is another issue when we start talking about carbon cycle. We're not going to go into those details today, but it is something to keep in your back of your mind, is that permafrost is capturing a lot of minerals and carbon that's held there and keeps our world in an environment that humans like living in. Okay, so now we finally get down to something we can use: lakes. Okay, freshwater surface lakes. So that is like, the Great Lakes have a lot of water in them. Okay, when we're in the Pacific Northwest and in Portland, Vancouver, one of the biggest ones we think of is the rivers like the Columbia River, but really it is a tiny, tiny fraction of the total water that is on Earth. Okay, so that is some of the measurements we're talking about here. All right, so if we look at those freshwater surface sources, the rivers and lakes, okay, remember there's a lot more in lakes than there is in rivers, but still, if we took a mile by a mile by a mile and filled it with water, we'd have 22,000 cubic miles of water, or 93,000 cubic kilometers a mile of kilometers of water, which means if we are good about conserving it and using it and keeping it clean, then we should have more than enough water for all of our human needs and all of the fish and all the other things that we rely on to live in these habitats. Okay, but the truth is, if we mess that up and we let the salt enter the environment, this lakes and rivers are only 1 out of 150th of a percent of the total water on Earth. Okay, so it really is a rare commodity to have all this fresh water. Okay, again, if you wanted to see the detailed numbers here, I'm not going to read them out, but you see there's a lot of different places where water is, and oceans, seas, and bays really dominate the total amount of water. Okay, so we're going to say this a couple of different ways, but we're looking at the water cycle. So where does it go from one to the next? So evaporation, like we saw in the picture, going from liquid to gas. Condensation, going from gas back to liquid. Transpiration is the one people don't think about, but it's a huge part when we think about all the trees and all the fields and all the grass. All those plants take in water through their roots and then let out the water through their leaves. They don't necessarily want to let out the water through their leaves, which is why things like cactus might be covered in wax to help hold that water in. But plants use that process of the water coming into the roots and out through their leaves. That those veins also carry minerals and vitamins up through the soil and up through the roots and into the leaves. So it becomes an important part of the plant cycle as well. Okay, but with so many plants on Earth, that really can be a major part of the water cycle, and it can contribute to major weather factors, especially if you're in a high plant or downwind from where a lot of plants are. So like if you're in the East Coast or the Midwest and there's all these cornfields upwind from you, they're all letting out water, and you tend to get thunderstorms late in the day as all that water evaporates, condenses, and then comes back down in a very turbulent fashion. Okay, sublimation, we talked about that in the picture. It's conversion from a solid, the snow and the ice, straight to gas. There's no intermediate liquid stage, so it's not technically evaporation, it's sublimation. Okay, and then what we talked about, when the water came down and it hits the soil, a lot of it is going to percolate and infiltrate the soil and come down and go back into the groundwater and refilling some of those aquifers that are so important. Okay, so now we have another picture showing that process of the evaporation, transpiration, so it's moving. We have surface transpiration or gaseous transpiration, not to be confused with transpiration. Okay, they do not help make this easy for us. So they're trying to say different ways of things moving, and moving through the plants is transpiration, just moving in general can be transportation. Okay, again, we have our sublimation, deposition, which is when it collects in any number of ways. Okay, and then again, we have that groundwater that came in on. All right, so looking at the assignment, or looking ahead to the assignment, we're looking at solids, liquids, and gases. Those are the phases of matter. So one of the columns we're going to see in the assignment is what phase of matter is it, or what two phases does it go from? Okay, so solid, liquid, and gas are your three choices. We don't have plasma as a water state on Earth, so we don't have to worry about anything more exotic, condensates, or any of those type of things. We're only going to look at solids, liquids, and gases. Okay, so evaporation, liquid to gas; condensation, gas to liquid; sublimation, solid to gas; and then transpiration, it's a little bit more complicated. It's coming through the plant and then it's being released as a gas. Okay, so when we look at the pictures, when we look at those geologic features, we saw the oceans, the lakes and streams, the groundwater, the glaciers, and then the mountain and the mountain snowpack, which I imagine we're going to be hearing a lot about as skiers start looking towards the mountains. What is the snowpack like on the mountains? So snowpack changes every year as it melts and then comes back. Glacial ice stays there year-round. Okay, all right, so that sets us up for the assignment. So what we see here is, I don't even know if this is, I'm trying to think if that is the best way to say evaporation. I want to go back and look at that picture. Okay, up here is where condensation's happening. Okay, So I would be condensation. Yeah, so I guess we can say H is evaporation. Yeah, that works. Okay, so I'm just trying to make sure you can come back and forth between these two documents and match up your plans, or you match up your water cycle. Okay, so that is part one. And then in part two, you're going to take this word bank and you're going to put it in here. And some of these you're going to use more than once, especially if you go down to part two. Okay, so one of the places was rivers and streams. Rivers and streams are liquids. Maybe they're solids every once in a while for a short period of time in the winter, but for the most part, rivers and streams, liquid. Okay, and then the process, evaporation. Definition, you can keep it nice and short. Liquid turning to a gas, which is exactly what we want to see in our phases here. Okay, and where does it happen? Well, evaporation mostly happens on Earth's surface. Okay, so when we looked at this, or if we want to look back at this one, okay, it can be on the ocean surface, okay, or it can be on the lake surface, all right, or it could even like during the runoff, you could see evaporation happen as well. Okay, so but those are all surface conditions. Okay, so that sets us up for this one. All right, so this weekend you finish this assignment, turn it in, and we'll be ready to talk more about cycles on the Earth next week. Okay, remember, as always, fill in your charts for your journals, the eco column every day, all right, or every class. And with that, have a good day.